up because they're saying, first of all, acknowledging that the low voltage option is there. Okay? Second of all, that it has separate kinds of benefits. Right? The door is opening. Yes?
I had a similar question. I got was that this line would give us access to wind turbine energy from Minnesota and the Dakotas, which seems to make sense because people in Wisconsin don't seem to want to build wind turbines.
Right.
And I don't know what year it is, but
2015, 10%.
10%. So if we don't build them here, it's got to come from somewhere.
But keep in mind on mandates for the renewable energy, we have similar mandates in Minnesota and other states as well. So they're assuming that there will be enough renewable energy built in these other states that they would be able to ship into Wisconsin. That is not necessarily the fact.
How many people here would rather have renewable energy and fossil fuel-free energy if you had a choice?
Depends how much it costs.
Okay, we'll bargain that. I mean, anyone knows anything about global warming? There's a lot of support for this, okay, very strong. So, one of the things that we did at the Low Power Meeting is we said, okay, you're going to provide high-quality renewable energy. Tell us what that will be. We don't talk about those things, okay? So since then, we've done some investigating, and this is what Tom's talking about. We have in Wisconsin a 10% renewable energy, and that's sold so that you have 100 units of electricity that are sold, that 10 of those units would be generated by renewable energy. That's the way it's done, by electricity, not by overall generation. In Minnesota, we have a couple of targets here. One of them is to have 30% by 2020. That's in the XL eastern kind of section of the state, excuse me. And then we also have a target of, what's the other one? 25% by 2025, I believe it is. But basically,
25 by 25.
Yeah, 25 by 25. Okay, so higher than Wisconsin. So the idea here is that we would bring the energy in from Minnesota and from North Dakota, South Dakota, hydroelectric power in Canada. It's a big meso area. I can show you another chart to show you how all the transmission lines run. Basically, or would run. The idea here is that we have to increase this output to make up for it. A big caveat to understand about renewable energy developments is that the federal government poured huge amounts of money and tax incentives during the stimulus package. Huge. It actually, if you look at the generation output of wind generation during that period of time, it is just astronomical gains that were taken. This is the actual growth in renewable energy from 2, 6, 7, 8, 9, 10. After 10, you can see even at the end of the stimulus package there, when part of the money was still left, that huge drop-off between 9 and 10, and now all of those programs, including the tax incentives, are gone. And the tax incentives were huge. You might know some about those. I mean, basically, investors were just kind of like a no-risk scenario with the instant return on their money. So it was a big push. The idea was, let's make this happen. Okay, so now we're in a predicament. We've had this big burst in wind generation. We have a slower economy. We've taken away the tax incentives to build the wind generation, and then in Wisconsin, we know we have a strange regulatory environment right now. It's hard to really tell exactly what our goals are. But that said, if we look, the Department of Energy has been struggling with this because the utility companies want to know how real, what is the future in terms of energy production? Where is the growth going to be? How should we design transmission? They have been working at this in the last 3 times that I have read their reports, this spring, the most recent. They have said that the best measuring tool or forecasting tool they can come up with is to say that if we take the 2009 figures, what was being generated in terms of renewable energy in 2009, and double those in the next 25 years, that will be a realistic figure under favorable economic conditions, not zero growth, but favorable, so that the economy does, in fact, kick back up into gear. Okay, so all we have to do is take them at their word here. Wisconsin, we're sitting at today, where we're sitting, actually the Public Service Commission has Wisconsin sitting at the end of 2009 at 6.1% of our 10% requirement, which is only about 250 megawatts of power short. And in their summary, they say that Wisconsin is favorably positioned to meet our own renewable requirements in state. Companies are favorably positioned to do that. In Minnesota, though, we're looking at 13%. Here's the pie. In the grid in Minnesota right now, or 2009, we have 55% coal going through the grid, 24% nuclear. We have natural gas, so let's say about 60% fossil fuel generated, nuclear, depending on how you want to consider that. And then we have wind at somewhere around 13%. It's exactly 13%. So if you multiply 13, we get 26, right? And that's by 2035. We're sitting at dealing with Minnesota being able to meet most of its renewable energy needs. So the question becomes, simply said, well, how reliable is this forecast? If we're going to be able to, here's the net environmental gain is real. Think about this for a second. Think of a grid as just a big square of lines all tied together. We have generation coming in at various points. If we increase wind, if we build a wind generation unit, the net environmental gain of that wind generation unit is only going to be there if what? We turn down the carbon, right? There's no inherent transmission requirement in this formula. If we have a grid sized but appropriately, and we introduce wind generation into the grid, all we have to do to get the environmental gain is to turn down the carbon. So if this is a business proposal made to me, I'm saying, show me the plan. Show me the carbon footprint. Show me what happens over time as you build your system, as you add more and more lines onto it, extend further and further. All of these lines are very, very expensive, and all of these connections are unknown. So it's a very, very reasonable thing for someone who's really pro renewable energy to say, okay, give us the carbon footprint. And one of those forms back there requests the developer to do that. Give us to it. And also in terms, a grid is what? A grid could be the state grid, it could be a regional grid. They're saying that they can't, the initial conversations I had with Dale today say, well, they won't be able to do that because it'll be coming from so many places they won't be able to do it. So I'm saying what you're telling me is that you're going to build wind generation here. You're not going to turn, there's no protections for turning down the carbon here. There's no plan to turn down the carbon here. And then you're going to build a big spigot on that grid in Minnesota, and you're going to run that across Wisconsin. Right? So now you've opened up the auditory, the area that you're going to audit, that you're going to have to do the carbon footprint on, but somebody has got to do this. The Badger Cooley line and the CAPX2020 lines are repeatedly defined as the opening or spigot lines for a Midwest plan. Here we are. Here's Badger Cooley, which is the high voltage solution. Remember that. And the CAPX2020 line here, which is the high voltage solution. Okay? Those exist here in the flow from east to west. And I can show you some market plans and stuff, but this will give you an idea of the network, depending on the numbers, $40 to $70 billion of infrastructural demand. And the blue lines that you see here in this chart, take a look at that, study that. Look at they're faint. Look how many faint blue lines there are. Those lines are these that are already built.
Oh, hold it up again.
Okay, so basically you can see that if you look at the nodal, these are all questions that should be asked. These are all questions. I'm not a transmission specialist, but one can go online and find these studies. This happens to be the study here. If you're curious about the graphic here, that is indeed, this is one of the studies if you read your ATC literature carefully, it will match the Strategic Midwest Area Transmission Study. There are several, about a dozen studies, but this is one of them. This particular line is estimated at $36 billion with 16,000 miles of